Hi guys, this video we're going to be looking at how to identify similar figures and what similar figures are. So last week we looked at what congruent shapes were, and they were shapes that were exactly the same in terms of sides and in terms of angles. So it had the same sides, same angles. A similar figure is a shape where all the corresponding angles are equal and all the corresponding sides are in the same ratio. So basically, if all the angles are equal, then and all the corresponding sides are in ratio, then the shapes are similar. Okay, so we can see here we have a picture of two triangles here, which have, we don't know what the angles are, but we can figure out if the corresponding sides are all in the same ratio. So the first one we can look at, see the longest side here is a ratio of 10 to 15 or 15 to 10. Either way, we can write that. So that can give us our scale factor if we write that out. So the ratio is 15 to 10, which we can turn that into a decimal if we would like, which is 1.5. So that's our scale factor if we're using that one side. And then we can test if it is actually the same scale factor for all sides, because they need to be all have the same scale factor. So 10 to 15, 1.5, 8 to 12, or 12 over 8. I'll do it two ways here. So 12 over 8. See how I've got put the larger triangle on top both times. So 12 over 8. 8 goes into 12 1.5 times. And then the last corresponding side is 9 over 6, which is equal to 1.5 scale factor. So they all have the same scale factor. So you can state that these shapes are similar figures. The other thing you can do is just take the smaller triangle. Once you've found the scale factor for one, see if it works for the other. So the scale factor for 10 is 10 to 15 is 1.5. 10 times 1.5 is 15. 8 times 1.5 is equal to 12. And then 6 times 1.5, so increasing by another half, would be 9. So that is how you're going to identify similar figures. So let's look at a couple more examples. So here we need to decide if these shapes are similar by considering the corresponding angles and the ratio of the sides. Okay, so if we copy this down here, let's look at the first one. So we can see that the corresponding angles appear to be the same. So the right angle lines up, the angles line up here, and this last angle does line up as well. So 5 would have to line up with 10. So 5 to 10, or 10 over 5, would give us a scale factor of 2. Okay, and then let's see if that applies to the other side. So the hypotenuse here, or the longest side, is 13, and here it is 26. So using our scale factor, 13 times 2 equals 26. So that works here. So the other way you could test that is just do 26 over 13, which gives you a ratio of 2. And then our last side is 12 to 24. And we can do the scale factor again. 24 over 12 equals 2 as well. So all angles are equal and all sides have the same ratio of 2. Therefore, they are similar. You would say they're similar. And you'll find out later in the video that if in a triangle all angles are equal, all corresponding angles are equal, then you'll find that the triangles are similar without knowing the side lengths. All right, if we look at this one here, we can see that all angles in here are equal and all angles here are equal. And we can't actually see whether the sides are in ratio. But what we can see is that all the sides in the first square are equal and all the sides in the second square are equal, which means each corresponding side will have the same ratio. Let's say that this side is all A and this side is B. The ratio for each corresponding side is going to be A over B. So A over B is going to be for all the sides, the ratio or the scale factor. So therefore, these triangles are also, these squares are also similar. We can have a look at this last shape here, and we can check if this is similar as well. So we can see they're both rectangles, and then we can get a ratio by looking at the corresponding side. So with the first one, comparing the 4 to the 2, so 4 over 2 gives us a scale factor of 2. And then we can look at the second side. 11 over 5 is equal to 2 and 1/5, or 2.2. So scale factors are not the same for corresponding sides. Therefore, they can't be similar. They can't be similar figures. And you need to explain that out using full sentences there. So while all the angles are the same, the sides are not in ratio. So therefore, you cannot say that they are in ratio. So just to recap here, guys, for a triangle to be, for shapes to be similar, all corresponding angles are equal and all corresponding sides are in the same ratio or have the same scale factor, which you can figure out by creating fractions between each corresponding side. Okay, so if you're completing up to 2-star, you can stop the video here and get started on the activity. And that activity looks at identifying whether these different instruments, violas, violins, cello, and bass, are in fact similar figures by looking at comparing their length and their width. So you'd figure out the scale factor by creating a fraction, say, between the viola and the violin of 42 over 60, and then see if that same scale factor still applies with looking at minimum or maximum width, so whether it falls in that range of being a similar figure. Okay? You compare that between the viola and the violin and the cello and the bass, and all of these, viola and the cello, viola and the bass as well. To identify which of these instruments are similar figures. So if you were doing 3-star, please carry on watching this video to have a look at a quick explanation of similar triangles. So with similar triangles, we actually have a few extra rules like we did with congruent triangles, but they're slightly different to the congruent triangle rules. So we know that there's 4 rule tests again to identify similar triangles, so triangles that have the same ratio of sides and the same angles. The first is if you have 3 of the same angles, corresponding angles in a triangle, the triangle has to be similar. And in reality, that means if you know 2 equal angles in a triangle, the third angle, because the angle sum of a triangle is 180, would have to also be the same. So really, this could be the angle-angle test, as long as they're corresponding angles. The next test is if all sides are in the same ratio. So once again, that's if you create your fractions. So DE down here over AB is equal to EF over BC is equal to DF over AC. So in this case, all the ratios are equal to 2, so they would have to be similar triangles. The third test is side angle side, but unlike congruent triangles where the sides have to be the same, these just have to be in the same ratio, and the angle has to be in between those 2 sides. So you can see 2 to 3 and 3 to 4.5 both have a ratio or a scale factor of 1.5, and the intervening angle is 40 degrees. And the last test is your right-hand side. So you've got a right angle, and then you've got 2 sides where one side is a hypotenuse that are in the same ratio. Okay, so they're the 4 tests for identifying similar triangles, much like we did with congruent shapes, just applying it slightly different rules in terms of looking for similar ratios rather than equal sides. All right, so good luck with this activity, guys, and please let your teacher know if you have any questions.